So, you're building a video streaming service. That's awesome. But here's the thing. You're not just building an app, you're building a fortress. And your most valuable asset, your content, is the treasure inside. So let's talk about how we secure that fortress, from the giant outer walls right down to the high-tech vault.
Here's our game plan. First, we'll look at the two big security fronts you're fighting on. Then we'll talk about locking your platform's doors. After that, we're going deep inside the vault to see how DRM actually protects your content. We'll also navigate the whole multi-DRM landscape, because it's a thing. And finally, we'll see how it all connects back to the code you're writing.
All right, first things first. It's super important to get this one concept down. Security isn't just one big problem. It's a battle you have to fight on two very distinct, but very connected, fronts.
Okay, so on one side, you've got platform security. This is all about your infrastructure, your backend servers, your APIs, your user database. These are literally the walls, the gates, and the guards of your fortress. And on the other side, that's content security. This is where we protect the actual video from piracy. This is the shiny, laser-guarded vault where you keep the treasure. And you absolutely 100% need both. A strong vault is useless if the front gate is wide open.
So, let's start with those outer walls, right? We're going to dive into the must-have technologies that lock down the platform itself and make sure only the right people get inside in the first place.
The absolute, rock-solid foundation of platform security is HTTPS. This is not optional, it's not a nice-to-have. It basically creates a secure, encrypted tunnel between a user's phone or browser and your server. Without it, anyone on the same coffee shop Wi-Fi could just listen in and grab login details or payment info. So yeah, it's the very first lock you put on your Fortress gate.
And for you developers out there, you can get this going pretty easily in your code. But in a real production environment, you're probably going to offload this job to a specialized piece of hardware, like a load balancer or an API gateway. Then be the dedicated guards at the gate, handling all that traffic.
Okay, so your user is inside the fortress. Great. But how do you stop them from just wandering wherever they want? That's where JWTs, or JSON Web Tokens, come into play. Just think of a JWT as a digital keycard. When a user logs in, you hand them this keycard. Then, every single time they try to do anything, like play a video, they have to show that keycard to your API to prove who they are and that they're allowed to be there.
But you gotta handle these keycards with care, right? And here are some pro tips for doing it right. The absolute most critical practice is to make them expire quickly. We're talking minutes, not hours or days. Why? Well, if a keycard ever gets stolen, it becomes completely useless almost immediately. For longer sessions, you use something called a refresh token, which lets the app quietly get a brand new keycard in the background so the user doesn't have to log in over and over.
All right, the platform doors are locked and bolted. Awesome. Now, let's head to the inner vault. How do we protect the video content itself, even after a totally legit user has access to it? Welcome to the world of DRM. DRM, or Digital Rights Management, is the magic that stops someone from just downloading your movie file and throwing it up on the internet for everyone. The core idea is simple. The video file itself is always encrypted. It's just scrambled garbage. DRM is the system that securely delivers the secret key to unscramble it, but only for the right user on the right device at the exact moment they hit play.
And this all happens through a super fast process we call the DRM handshake. Let's walk through it. First, you hit play. Your video player sees the file is encrypted, and it talks to a special secure chip on your device called the Content Decryption Module, or CDM. Think of the CDM as a tiny, unbreakable safe built into your phone or browser. That CDM creates a request for a license and sends it to your backend. Your backend checks the user's JWT keycard and makes sure they're a subscriber. If everything looks good, it forwards that request to a special DRM server. That server sends back a license with the decryption key, but it's locked in a way that only that specific CDM can open it. Finally, the CDM uses that key to decrypt the video, in real time as you watch. And here's the key. A decrypted, copyable video file never ever gets saved to your device. It's pretty slick. Now, you'd think there'd be just one DRM standard for this, right? One key to rule them all? Well, nope. Surprise. The reality is, different browsers and devices all use their own DRM systems. So if you want to reach everybody, you need a strategy for what we call multi-DRM. And there are really three big players you have to deal with. For pretty much anything Google, Chrome, Android, Firefox, you need Google's Widevine. For the entire Apple universe, iPhone, Safari, Apple TV, you have to use their system, Fair Play. No choice.
And then for a huge number of smart TVs and game consoles, like the Xbox, you'll need Microsoft's Play Ready. The takeaway is simple. To make your service work everywhere, you gotta have all 3 keys for all 3 of these different locks.
And here's another pro tip for you. Not all DRM protection is the same. Even within one system like Widevine, there are different security levels. L3 is basic. It's all done in software. It's okay, but it can be cracked. The gold standard, the one that really matters, is L1. With L1, the entire decryption and video processing happens inside a special, secure part of the computer chip itself. It's a hardware-backed bubble. And here's why that matters. If you want to stream content in HD or 4K, the movie studios will literally put it in your contract that you must support L1 devices. It's a non-negotiable for premium content.
So, we have our platform security, and we have these different DRM systems. How on earth do we connect them? Well, this is where your back-end code, the application you're writing, gets to play the really important role of being a trusted broker.
Let's look at that handshake one more time, but now from your back-end's perspective. Okay, a license request comes in from a user's device. Your first job is to be the bouncer. You check their JWT key, you look them up in your database. Are they a paying customer? Are they allowed to watch this? If the answer is yes, you act as the broker. You make a secure call to your third-party DRM provider and pass along the request. The DRM provider sends back the license, and your backend just passes it straight down to the client. You're the one connecting the dots, without ever needing to handle the secret keys yourself.
And this right here is the #1 takeaway for any developer getting into this space. Do not try to build the DRM system yourself. Just don't. It is an incredibly complex, specialized field. Your job, your real value, is to build the application logic, manage your users, and be that smart, secure broker that connects your authenticated users to a powerful third-party DRM service that does the heavy lifting.
So there you have it. By securing your platform's walls with things like HTTPS and JWTs and locking your content in a multi-DRM vault, you can build a really solid fortress. But look, the battle for security is never really over. It's a moving target. As tech evolves, so do the threats. And that leaves us with one final thought to chew on. Now that we've got this fortress secured, what do you think the next big fight in content protection is going to look like?